Hello, welcome to my 4D videos on electricity and magnetism. If you already haven't checked out my first 3 modules on my YouTube channel, please do so and follow the links. Now let's have a look at 4D. Analyze the effects of a moving charge in electric field in order to relate potential energy, work, and equal potential lines by applying V equals delta U divided by Q. Now U is potential energy and Q is the charge. Now we've got here V is the potential difference through which the charge moves in volts. Now let's have a look here at the few dot points that I got on my slide. So electric field lines go from positive to negative charged objects. You can see that in the diagram. Positive charge carriers will move in the direction of the field and work is done by the field. Negative charge carriers move against the field and work is done by the field. Okay. Now, negative charge carriers will move against the field. So this is going towards the positive. Positive charge carriers go towards the negative. Okay, and follow those equal potential lines. Now let's have a look at a few questions here that will help you understand this. So use the following information to answer the next 3 questions, and I'll give you the opportunity now if you'd like to pause the video to have a go at this question. Okay, let's have a look here now at this question. So 3 points X, Y, and Z are points in the uniform electric field are at distances D and 3D apart, respectively, as shown in the diagram on my PowerPoint slide. It takes 3.3 times 10 to the negative 6 joules to move a charge of 1.6 to the negative 8 from X to Y. How much work will it take to move the charge from Y to Z and justify your answer? We just times it by 3 because the distance is 3 times more. So you got 9.9 times 10 to the negative 6 joules. You can see that in my working out. 2. What is the potential difference between X and Y? Now, we know that you just learned the equation V equals U over Q. We can use work as U, which is potential energy. So sometimes textbooks would use W instead of U. And you've got here V equals U over Q. 3.3 times 10 to the negative 6 divided by 1.6 times 10 to the negative 8, and your voltage is 206.25. Now, what would the potential difference be between Y and Z and justify our answer? Now, because the distance is 3 times greater than X and Y, we just times that voltage from the answer to 2 by 3, and you get 618.75 volts. Now, let's look at another question on this next slide, and if you like the opportunity now to pause it. Okay, points P and Q are 10 millimeters apart in an electric field. The direction is not shown. When the charge of positive 8 microcoulombs is moved from P to Q, the field does 4 times 10 to the negative 5 joules of work. 1. What is the direction of the field and justify your answer? 2. Describe the motion of the charge from P to Q and justify your answer. And 3. What is the potential difference between P and Q? So let's have a look at my responses. So the field is directed from right to left. The charge is positive, so if the field does work, then the field is in the same direction as the movement. So you can see that there by the positive charge given in the question. Now, what would happen and describe the motion? It's accelerated from P to Q as the force is acting on it. Okay, so it's going to be moving from P to Q and accelerates in that direction. It just goes with the flow, the positive charges. Okay, and we just learned that from our theory. Now, what is the potential difference? You just use V equals U over Q. V equals 4.0 times 10 to the negative 5 divided by positive 8 times 10 to the negative 6, and your voltage is just 5. Okay, it's pretty simple. This is very easy compared to my previous video on 4C, which I looked at 3 equations. This is just 1 equation. We'll knock this off easily in a lesson in class. Thank you for watching. Stay tuned for my next videos that I'm going to be looking at series and parallel circuits, electric current in metals, and looking at ferromagnetic materials and magnetism in general. Thanks for your support.